So when you hear the term 3D printing, what actually comes to mind?
For most people, right?
Yeah, for most people. Is it just, plastic trinkets,
Yeah.
little hobby kits, maybe something you saw on YouTube?
Definitely. I think most people still sort of file it under futuristic toy.
Exactly. Something that tech enthusiasts are, tinkering with in their garage.
But the stack of sources we process today, well, they paint a fundamentally different picture. They argue that 3D printing or additive manufacturing is shifting really fast from this niche curiosity to what one of them actually called a universal tool.
A universal tool. Okay, I like that. So let's unpack this. Our mission for this deep dive is to go way beyond the mechanics, the extrusion, the sintering. We've kind of covered that before.
Right. The how is established.
Exactly. Now we're asking, what does having one of these universal tools on your desk or in your workshop actually do? How is it rewriting the rules for everything from design to commerce?
We're really diving into the practical real-world uses to prove this isn't just for a small group of tech fans anymore.
It's for anyone who needs to solve a physical problem.
Precisely. We're going to map out the whole spectrum, starting with, a simple, satisfying fix at home, and then moving all the way up to these massive industrial shifts that are, and this is not an exaggeration, saving lives.
Let's start right there at home, because that's where the power shift really begins, right?
It is. The sources all highlight that the biggest change is taking power out of a big, centralized factory.
And putting it right in your own garage or your home office. This is that personal manufacturing revolution we hear about.
And what's so fascinating is how much the sources emphasize the immediate, practical stuff. It's not just about making cool art, it's about making something work again.
Oh, I know exactly what you mean. That feeling of complete frustration, that Achilles heel of modern products, planned obsolescence. I swear, I spent maybe 3 hours last month trying to find this tiny plastic widget for my washing machine door. And of course, the manufacturer decided it's proprietary. You can't replace it.
Of course. And that little plastic piece, it probably cost them pennies to make. But they'd rather you buy the entire $80 door assembly when it breaks.
But with a 3D printer, you're looking at, what, 50 cents of filament?
Yeah.
And an hour of your time to either design it or, more likely, just download a file someone else already made.
And that one small act is so incredibly powerful. It's not just that you're saving money, though you are.
No, it's so much bigger. It's a huge win for sustainability. You're directly extending the life of a product that a massive company decided was disposable.
You're creating a little circular economy of repair instead of just replacement.
And you don't even have to be a brilliant engineer to do it, right?
Mm-hmm.
The ecosystem is already there.
It's remarkably robust. The sources kept pointing to these huge digital design repositories, online communities where millions of people are sharing files, these STL files. You just search, download, and print.
It's like DIY manufacturing, but crowdsourced from the entire planet.
Exactly. And that same digital ecosystem opens up a whole new world for hobbies and fun, moving way beyond just repairs into some really complex customization.
Yeah, if you're into something like board games, for example,
Yeah.
you're normally stuck with whatever the company decides to put in the box.
But 3D printing adds this layer of personalization that was just impossible before. You can create these unique, super detailed figurines, custom terrain, special tokens.
It makes the whole experience so much richer. You go from being just consumer of the hobby to a producer within it.
You basically become your own niche market creator.
Or think about something like cosplay. The community there has these incredibly high standards. You need a piece of armor or a helmet that fits you perfectly.
To the millimeter. Something that conventional molding could never do without, just astronomical costs for a one-off piece.
Yeah, it turns a hobbyist into a custom artisan practically overnight.
It all just boils down to the ability to create unique things that you can't buy in a store. Your vision is suddenly more important than the constraints of the mass market.
So whether it's a special camera mount or a part for a radio-controlled plane or just the perfect vase for that weird little corner in your house.
Your imagination becomes the only real production limit.
So, okay, we've covered the home front. Repairing things, customizing your hobby.
Right, the personal manufacturing side of it.
But we really need to pivot here because as cool as all that is, the real revolution, the one that's actually reshaping global supply chains.
That's happening on a totally different scale in the professional sphere.
And medicine seems to be leading the charge. This is where personalized manufacturing becomes just critical.
It's the definition of tailored care, the ideal use case.
Because every device has to be custom made, uniquely suited to one specific patient. And the whole thing starts with their data, like a CT scan or an MRI.
And that precise data gets translated into a physical object. So doctors can get these 3D printed anatomical models, I mean, an exact replica of a patient's tumor or a complex bone fracture.
So they can plan everything out before they even walk into the operating room.
Meticulously. It cuts down on unforeseen complications and just dramatically improves the outcome of the surgery.
And these are not just for looking at, they're for planning, for training. But it goes beyond models, right? I mean, printing actual skull implants. That sounds like it needs a whole other level of sterility and regulation.
It does, but the sources are extremely confident here, and the proof is that it's already happening. We are talking about printing surgical guides that help a surgeon be more precise during the operation.
And then the final implants and prosthetics themselves.
That conform perfectly to that patient's body.
And this is where our research turned up something I found genuinely surprising. It's about how established this technology already is. In countries like the Czech Republic, many of these custom-printed devices, like skull implants, they're already covered by health insurance.
Wow. Now that is a critical insight. That tells you this has moved far beyond the experimental phase into standard medical procedure.
It must have.
For a government-backed healthcare system to pay for it, that means it's gone through regulatory approval, there's trust in the materials, and it's been proven to be cost-effective. That is a massive stamp of approval.
Okay, so medicine is at the forefront of this custom responsive manufacturing. But what about just sheer scale? Let's talk about architecture and construction.
Right. We're going from the micro to the massive. Originally, 3D printing was just a tool for architects to quickly make those detailed physical models of buildings.
That's a cool way to show a design to a client, yeah.
But that technology has scaled up exponentially. Now we are seeing these giant specialized printers that can literally extrude concrete mixes.
And print the walls of an entire house. Right in the building site.
It's incredible to watch.
Printing a house.
Yeah.
So what are the big benefits the sources are highlighting there?
It's immediate and it's tangible. First, speed. Construction times are just dropping dramatically. You could potentially print a single-family home in a matter of days. And second, there's so much less material waste compared to traditional methods where you're always cutting and shaping. Now, there are still challenges, with materials and building codes, but the speed and efficiency are total game changers.
So if it can handle massive scale in construction, it must also excel at the other end of the spectrum, hyper-precision and speed. Things like mechanical engineering, aerospace.
And that is where we hit the one key term that came up in every single source, rapid prototyping.
Rapid prototyping. Okay, let's unpack that. What does cutting down development time actually look like for a company designing, say, a new jet engine part?
Well, historically, if an engineer needed a prototype for a new bracket on that engine, they'd wait weeks, sometimes months for traditional manufacturing, like casting, to deliver it.
So the whole project just stalls while they wait.
Exactly. With rapid prototyping, they can send a new design file over in the evening and have a physical component in their hands ready for testing the next morning.
Hours instead of weeks.
That
efficiency lets them try 10 designs in the time a competitor tries one.
It completely changes the competitive landscape for any kind of complex engineering.
And it's not just for prototypes anymore, is it? They're using it for the final parts that go into the plane.
Absolutely. The sources really stress this. 3D printing offers material advantages that old-school subtractive manufacturing just can't match. For aerospace, everything needs to be lightweight, but also incredibly strong.
And how does printing achieve both of those things at once?
By letting engineers build these incredibly complex internal geometries. Think of it like a digital honeycomb. These internal lattice structures inside the part.
Structures you could never create by carving a block of metal.
No way. You can't access those internal spaces. So with 3D printing, they use less material, which makes it lighter, but they distribute the stress more efficiently across that internal webbing, which makes it stronger. It's a massive technical advantage.
Wow. So we've gone from fixing a dishwasher latch to creating custom game pieces, to planning brain surgery, printing houses, and making jet engines lighter and stronger.
It's a wildly diverse list of applications.
It really is. So what's the common thread here? What is the fundamental idea that connects all of these different uses?
That is the big question. And the answer is the single economic and technological shift that the sources call the democratization of manufacturing.
The democratization of manufacturing. Okay, that sounds like a really powerful concept, but let's ground it. For an average person or a small business owner, what does that actually mean?
It means that the power to turn a digital idea, a CAD file, a 3D scan, into a functional, physical thing no longer requires the huge capital investment of a traditional factory.
That creative power, which used to be locked up inside massive corporations,
Is now accessible. A small startup can now use production methods that were once reserved for, a General Motors or a Boeing.
allowing them to compete in these very specific, high-precision markets.
Exactly. It lets small teams innovate and iterate on products with incredible speed, targeting these niche markets that mass production would just ignore because they weren't profitable enough. It disrupts the old model by making innovation fast, accessible, and totally customizable.
And that, I think, is why this matters to you, the listener. It doesn't matter if your personal goal is fixing something at home or if you're in a team designing a new medical implant.
The underlying power is the same.
The ability to innovate quickly, to turn a digital blueprint into a physical reality, has just never been more attainable.
And once you realize that, the breadth and power of it all, it naturally leads you to the next logical step, which all the sources were pointing towards.
Getting started yourself.
Right. Because once you see all these amazing applications, the next question is unavoidable. How do I get the right tool for my job?
Absolutely.
Yeah.
It's clearly not about just buying any 3D printer. It's about matching the machine's capabilities to your specific goal.
Indeed. And that sets up a really interesting problem to think about. If the applications range so wildly, from a simple keychain to a life-saving custom implant, what specific decision criteria? Beyond just the obvious price tag of cheap versus premium, what must you prioritize when you choose the machine that's going to create your particular amazing thing?